Hi, everybody. My name is Keith Belanger. I am the product evangelist here at SQL DBM, and I will be the MC and host of our two other panelists today that I look forward to having conversations with. I'll kind of turn it over to them to introduce themselves. Kent, if you want to give yourself a little shout out.
Yeah. Hi, everybody. Kent Graziano, the data warrior. Happy to be here and talking about data modeling and doing data modeling for multiple decades now on multiple platforms. Most recently, I was the chief evangelist for Snowflake for a little over 6 years before I kind of went into semi-retirement and just do these sort of things, do some webinars and fireside chats and a little bit of advising here and there. But yeah, happy to be here and excited for the conversation.
Great. And I laugh at semi-retirement because I think I see you more around now that you're semi-retired than when you when you were retired.
The
Um,
beauty of social media.
right. And our other panelist, Marcin, if you want to introduce yourself, that'd be great.
Hey guys, Marcin Kulakowski here. I've been working within this industry for many years. I've been doing modeling for many years. So my career started with BNY Mellon for a couple of years. Then I went to do a big data warehousing project with Moody's Investor Services. And then for over 15 years with Fidelity Investments, wearing many different hats. And lately, for about 4 years, 4 years will be in September, I believe, with Snowflake as a senior solution innovation architect.
Great. Thanks for joining us, Marcin, and happy to have you on our panel. Same Kent. For those of you, we are going to just have a we're calling it a fireside chat conversation around a couple of data modeling topics, but please feel free to drop into the Q&A some questions. We'll try to get to your guys' questions as much as we can. We want to make sure you guys are getting the most out of this. But we're going to get underway with some questions for ourselves, and I'm gonna start it with you, Kent. And why do organizations need to do data modeling? Why is this important?
Well, data modeling gives you if nothing else, the map and understanding of the data in an organization. At a very high level, if you're just talking conceptual models, it gives you, really, we used to call them the subject areas, or now I think we would call them the domains, right? What
Right.
what is the information and the data that your organization is concerned about? How is it related across the organization? Especially now in the data mesh world, when people talk about having domain teams, as how is the finance data related to the customer data, related to the manufacturing data, or in healthcare, your patient data, how is that related to, say, clinical trials and diagnoses and prescriptions and the pharmacy and all that, as well as the providers and even the locations. Where is all this happening? And so it helps you get that, at least that high level understanding to begin with. And as we have moved forward in this age of LLMs and Gen AI and all that, it's somewhere we have to be able to record all of this. Even in the data warehousing world, it was very important to understand at a detailed level what the data was in our source systems, and then how did we structure it inside of the data warehouse for effective analytics and forecasting and things like that. And it's just a lot easier for what we used to call the knowledge workers, now you might call them citizen data scientists, to do their work and take advantage of that data if they have a better understanding of it. If the data models really of all kinds, whether it's the conceptual model, logical model, or the actual physical model of the data in the databases, it gives you that metadata to understand the relationships between these different data elements rather than having to try to guess.
Right.
How is this related? I mean, the basic stuff of, can a customer have more than one address? Without having to go query the data to know that, it's good to know that ahead of time as you're doing your analysis. And so even things that are that simple, it's very important to have. And as they always say, picture can represent 1,000 words, right? And you can give someone a diagram, a data model diagram, and work with a business person, assuming your diagram is, showing business terminology, to really walk them through the data in their organization and validate, is this how you use the data? Is this the data we're really concerned about, that's going to be useful even for running your business, for whatever projects you've got going, whatever analytics you're trying to do, just as a review mechanism even.
Right.
Just having those data model diagrams is invaluable. It's a great way to explain it to people, way better than, back when I first started. A lot of times people would just ask for a data dictionary. Okay, well, now we would call that a data catalog, but back in the old days, it was like, okay, we're printing out, a list of table and column names and maybe some little descriptions and some data types. And as your organizations got bigger and the data landscape got wider, that's just too much for somebody to scan through, because it's
Right.
like reading a novel, right? You're reading a Tolstoy novel now with all these arcane terms that really don't make any sense to you. And you throw it up in a picture on a big screen TV now, or on a Zoom, and it's a lot easier to walk through and show people, and they see the lines. You see a line between two boxes that have names you recognize and go, oh yeah, okay, yeah, customers are do have addresses, right? And we have more than one address for a customer. We have more than one phone number for a customer. Things like
Right.
that. It's a lot easier to have the conversation and explore the content of the data and the meaning of the data by having a data model that is easily shared with others.
Yeah, I mean, I found it as a great one to confirm my interpretation in my conversations with the business, that I was, understanding what I was hearing, versus, remove any biases I might have had, and I think one thing I found is people who are not having those conversations with those folks in the organization, right, to get that real picture, and also to identify where you have inconsistencies in the business's interpretation of a thing. Like one might say, oh yeah, we can have many, to use your address, I can have many addresses, and somebody else says, no, they can only have one address. It's like, okay, we have some inconsistencies in the model here, and bring those through. So yeah, I found when I was mostly doing a lot of data modeling in practices was really being able to, in my way of documenting my interpretation of the organization and how data related within that organization.
Right. And in reality, you're documenting business rules. Right.
Right.
So like you said, you may have made some assumptions based on what you saw in one database, but then you go talk to the business people and they go, oh, no, that's not always true, which
Yeah.
is more often the answer, right? Okay, yeah, it was true in this situation, but it's not always true. And here's the situations where it's not true. And now you're really starting to understand what we call the business rules. What are the
Right.
rules within the organization on how the data is structured, how the data is used, what the relationships are. And that's the only way you're going to find that out, is actually to be talking to the people, as we now would call them, the domain experts, the domain subject matter experts
Yeah,
that
but
can tell you.
going back to that the original question, why is it important to the companies, right? I mean, every company relies on the data, right? It's the most important asset behind people, right? I would assume. I mean, data is the most, if you organize well data for each company, you can go as far as like you can build, the most reliable systems, and you can rely on that data and build like anything you want, right? All the systems will be built accurately and with simplicity and flexibility if we do that modeling properly.
Yeah, absolutely. And kind of, Marcin, to kind of go off of that, a few months back, I think it's been a few months now, you had actually written a blog and kind of spawn off some of this conversation today in terms of, how can organizations determine that the monetary value of data modeling? Can I go into that a little bit?
Yeah, so I thought about monetary value. It was like about 15 years ago. There was a lot of misconceptions. Why do we need data model? Why do we need a beautiful picture? Why do you put a beautiful picture in front of us, right? I mean, and that gets me thinking about it, right? Let me think about like what's the real value, right? Not just conceptually, oh, it's data quality, this and that, right? Yes, it's all that, but the real value is where we do the data modeling and we when we reduce the maintenance system maintenance costs, right? And we build better requirements definitions and with reduced maintenance, right? And in terms of error corrections, we bring in like simple principles, right? We bring in functional dependencies, which data is placed where it belongs, really. And the data modeling itself provides rules to determine that functional dependencies, right? And reduce the misplaced, the incidence of misplaced data. And which is, in reality, it's harder to correct and eliminate needlessly redundancy of data, right? But on top of it, we can talk about things like, easier change management, right? Because data models provide single source of data knowledge, right? And change is easier to apply later on, right? If we have that in front of us. I think also it brings up this question of better system integration, right? This is like major requirements today due like to prevalence of like mergers and acquisitions. And this is all like all those benefits translate directly into like value propositions for data modeling, right? And this value proposition can bring like innovation, services, feature to make a company produce better products and be situated in the market space, right?
Yeah, I mean, I have seen, in working with many organizations that don't necessarily have modeling as a practice, but at the same time, going in from a Snowflake perspective, and where really consumption is the bad modeling, bad design, higher compute, you know, more processing on bad data quality. A lot of, is that the monetary impact for not doing data modeling, right? In terms of overcoming that with, code and compute and a lot more of cleaning up that data that maybe could have been not had to been managed or handled if you'd done some, earlier on data modeling and designing on that as well.
Yeah, so all of that costs money, whether it's,
Of course.
More compute than you need because you have an inefficient design in the underlying database, or the time it takes to write the code to figure it out, right? And how you're joining the data. Maybe you're joining the data wrong, which could, if you don't really understand the relationships in the data, you could be producing a bad analysis, even though the data might be great. But if you don't have the understanding of the underlying data and the relationships between the data, you could easily write a query that gives you bad results, which could have other consequences and costs to your business, let alone just somebody figures out that the answer is wrong. And now your data engineers and your analysts are spending time, which of course is money, to go figure out what's wrong with this query. Why is this result not right? And then you're sort of backing your way into the understanding of the underlying data model that you really didn't understand before.
Yeah. Yeah. So actually, I'm going to put another kind of reminder, everybody. If anybody has any questions for us, please do not hesitate to throw them into the QA. And as I see them, I'll kind of throw them out to the panelists here. But I'm going to have a new kind of a question of my own. We see here in the poll at the moment, there's about 24% of the people that are joining us, that data modeling isn't part of their practice. And I know when I started, many years ago, in terms of it was at least for many of the people, the organizations I worked with, it was the practice. It was standard operating procedure to do data modeling. But over the years, it kind of disappeared. And, I'll ask Kent, start with you, like, why do you think it disappeared? Like, why do you think it kind of fell off? And maybe it's kind of started to make a comeback, but I do know it really did fall off for a while there.
Well, yeah, there's two two reasons, I think, for that, really. And part of it is they stopped teaching it
Mm.
at the college level. I mean, I don't think I've ever seen it actually even taught at the high or discussed at the high school level, but you get into colleges and universities, and we got into computer science, right? And then more and more we've gotten into this technical engineering, writing Java, writing Python, and that became more of a focus that, the data modeling classes just weren't there. I spent, when was this? Oh, over a decade ago, I worked with the master's program at my university in Denver, and we actually taught data vault modeling and star schema modeling and all of that. And that was at a master's level. So these are people that already had experience and might have had bachelor's in computer science, and it had to be a master's in business intelligence before anybody started talking to them about data modeling. And that's pretty late in the game. And I think over time, yeah, you're hard pressed now to find university programs that teach, just the basics, entity relationship modeling, what is normalization, all the things that Cod and Date wrote about.
Yeah.
And that was 50 years ago. It's been 50 years. I got to see Dr. CJ Date a couple of weeks ago at the Data Vault conference, right? And it's been, 51 years now since that first paper on relational. And so it's, a little bit out of sight, out of mind because it's been so long. But then we had the big data era, and especially the NoSQL era, where we started talking about schema on read, right? That, the idea of doing a data model in advance got panned quite badly because of bad experiences. When I started off early on, big enterprise data modeling projects would literally take years, and it might just be the logical model. And then they'd hand it over to the Oracle DBA, and the Oracle DBA is like, well, we can't implement this.
Right.
It's not going to work. It's not going to perform. And so you had, literally $1 million projects spent just spending time developing a data model, doing all the things we're talking about, but they hadn't gotten into the idea of agile and how to do things in smaller increments. And so it just got a really bad reputation, as did data warehousing for quite a while, that these things take too long, they cost too much, that they don't deliver value. And so the combination of that, and then the NoSQL world coming out and saying, we don't need no stinking schema. We can do schema on read after the fact. That became a big thing, because even when I started first at Snowflake, there was a group of people that said, well, yeah, we don't, customers don't need to have a data model in Snowflake because Snowflake performs so well. And like, okay, to a certain extent, that's true. And then working with the semi-structured data like JSON, Snowflake built some really awesome capabilities. But in the end, what I got to determining and working with customers was you still ended up having to have a data model, because you can load all the documents you want and, JSON and XML and all of that, but you still have to understand the structure, and that is a data model, right?
Yeah.
In order to pull it out. And so I think just, the combination of a lack of emphasis at the academic level, and then just the technology. And I'll have to say, the vendors saying you don't need to do this because we're trying to get the projects going faster, right? And it's like, well, oh, no, don't take 3 months doing a data model. We want you to just load your data in and start querying it, right? And so, that, as you already said, has some additional costs of, if there isn't a good design, it might be actually costing you more money to do that than if you had spent, even a couple of weeks thinking about the design before you put it in. And just because you had all this power, especially we went from Hadoop and NoSQL to the cloud, you have all this power. It's like, okay, yeah, we don't have to worry about performance tuning as much. But yeah, it's really as much. You still need to think about it.
Yeah,
Exactly.
I do lack of academic, right? No one teaches you data modeling anymore. But also technology. Technology is like it's bringing you new ideas, new tools, right? So maybe someone is creating that startup company, right? And using that Ruby framework or something like that. It'll be like easier for them to deal with sort of and creation of data model out of the box than creating model, on their own, right? So So I think it'll be, with technology, it just got easier and slappier, in my opinion. But you have to, once eventually the company is mature, you have to go back and reverse engineer, and you have to look at these entities, right? You have to create the logical data model, or maybe conceptual data model if your company is big enough, right? To look at conceptually at all the business units and entities, right? At that level. And then eventually, just keep doing this whole data modeling practice, right? I mean,
Yeah.
yes, tools can give you only a start, but you have to keep doing it on a regular basis.
So we're getting some questions. This is great. A few. One of them, I see yours, Steve. We'll get to yours because was a topic we were going to bring up anyway. So I'll get to yours. But question we have here, and I think we can throw it at you, is what's the best practice for dimension changes? I feel like it's very hard to remove and add new relationships on models.
Yeah, that's always a challenge, whether you're talking dimensional models or third normal form models, is finding out after the fact that you've missed a relationship. Scott Ambler did an excellent book on refactoring data models. So I absolutely recommend that. It's still not easy, but he's got a very methodological approach for if you have to change your data model because you got new information, the relationships weren't there. My standard answer is start off with data vault models before you build your dimensional models, and that makes it a lot easier. Yeah, because the data vault approach is so highly normalized and it abstracts all the relationships into what we used to call intersection entities. They're called links in data vault. And in my practice over the last pretty much 20 years now, for data warehousing for analytics specifically, and you said dimensions, so I assume you're talking about analytics. We built the data vault model in an incremental fashion and then use views. And this certainly absolutely works in Snowflake. I've done it in Oracle. I've done it in SQL Server. Doing views for the dimension models for the user interaction. And then when things change, it's a lot easier. The data vault model is designed to be adaptable and expandable and more robust in that way. And then it's a matter of building a new view with that incorporates those new relationships. And that's a lot easier than if you're writing really complex ETL code to resolve all these things and build tables, and then you find there's a change, right? So it's a different architectural approach, using the data vault as your core repository of historical data, and then using basically virtual data marts on top of that, and that eliminates a lot of the effort and the backlog. It's just a lot quicker to do to modify a view than it is to rewrite and re-QA a whole bunch of ETL code if you find that your dimensional models have problems.
Yeah, no, exactly. And kind of another second on the data vault was one of the reasons why personally myself, I went from doing straight dimensional and Kimball method to data vault, because I too was in a scenario where, when I first started doing data modeling, and data warehousing, I had one source system, the mainframe. And then, 15 years later, I had over 250 source systems between APIs and, IoT devices and on and on and on. And then, maintaining. So, those of you who haven't looked at it, definitely look into the data vault practice in terms of how that can help with the multiple sources.
I'm actually a big fan of third normal form data modeling. In my opinion, if you model properly everything in third normal form, you don't need anything else unless you need specialized, reporting, which is Kimball dimensional data modeling. Data vault, yes, it's all nice. It's flexible, agile, and it's easyable, extensible for adding new data sources, but it requires expertise, right? It requires this, building a data warehouse, and it requires this appropriate use case that you can utilize this type of practice. But once
and of course, like you said, a good third normal form model that's, I'll say, business based, right? That is really semantically based is great place to start. That's where I've always started with those. And certainly for operational systems, third normal form is certainly the only way to go. But I think that the challenge some of the people have, though, is that, the incompleteness of the analysis that leads to them having to try to change things in the database later in the game, and it gets very costly, regardless of what the original modeling approach was. But as we just said, from an academic perspective, so few people are trained and really understand normalization that, trying to get that third normal form model, any good model is a challenge, right? It's hard for people. You've been doing it a long time. You're like, we've been doing it a long time, and
I think it's easier to do a third normal than data vault, in my opinion.
Well, we could have a long debate about that, so we won't do that one here, though.
We're gonna have another conversation, another fireside conversation on that.
Yeah. So, I'll find you at Summit, and we'll have that conversation.
So this actually brings up, there's another question here, and I'm sorry, there's another one, I'm going to skip it, but it kind of transitioned to this other one. So we're talking a lot about third normal form and modeling, and we talked about relationships, but this question here is, with many of the cloud platforms, especially, even with Snowflake, right? Constraints aren't enforced. So how do you implement checking for uniqueness, referential integrity in these implementations? So throw it out there. I don't know if Marcin, you want to take that, or even for Kent, if you want to kind of take that one in terms of like, I have some of my thoughts on this is, I would build into my ingestion and processing processes, the checking, right? So making sure I have uniqueness, making sure I have some level of referential integrity. The database isn't in these scenarios necessarily going to do it, because you don't do it because processing millions of rows, right? You don't want that overhead to say check row 1, check row 2, check row 3, but doesn't mean you don't check it, right?
Yeah, well, and I think part of the question is people looking in the database, and like there's no primary keys and no foreign key constraints defined at all. One of the things I discovered, a couple of decades ago, honestly, was doing disabled constraints. Right, it worked really well in Oracle and SQL Server, and yes, it's Snowflake. They're not enforced, but putting them in doesn't slow down the processing if you've got them disabled. And that was the main objection that I always ran into, is people said, hey, well, it's going to slow down our ingestion. It's like, well, it's not if you disable the constraints. And so we actually developed a mechanism in the Oracle world where we put disabled constraints in the data warehouse, and then after the load, we would go through and systematically enable them. And if they failed, that was a pointer to a data quality problem that we could then mitigate. Now, for the people who have a database already, this one here said they have 471 tables in SQL Server. You can start by trying to reverse engineer those tables into a tool like SQL DBM, which has a utility for inferring foreign keys, basically based on matching column names and data types. And so that's a great way to kind of get started, right? So you can try to identify things that way, but it's really very useful to use, a data modeling tool that has these capabilities built into it. And I swear I spent a couple of decades doing that, because I had the same problem nearly every organization I went into. They'd say, oh yeah, our data's great. And you go look at it, and there's no foreign keys, there's hardly any indexes, there's no primary keys. And step one was reverse engineer those tables. I won't even call them a model at this point. Reverse engineer those tables into a good data modeling tool, and then incrementally start going through and validating and adding the primary keys, adding the foreign keys. But you have to do it, from an agile perspective based on business priorities. Where are you having problems? Are you having performance problems with a particular aspect of the data? What's the most important to the business? And start looking at that part of the data first. Don't try to do it all. You got something 471 tables. That's a lot of tables. So you have to find the ones that are key, that are going to drive, you're going to be able to drive the most value from understanding the data better, and start there.
Yeah. One thing to add, I've seen, and I'm looking at the one without foreign keys and primary keys, and myself, I started, like you said, Oracle, where, you would have to not have these constraints. And I've seen some of those practices, for example, translate over to Snowflake, but many don't know. And I would kind of curious to get Marcin's kind of take on this as well, is that even though Snowflake doesn't enforce the constraints, if you're adding your foreign keys and primary keys in Snowflake, it helps the optimizer, especially if you're doing join eliminations in your queries. It helps the optimizer in Snowflake understand how these tables are related and can increase your performance up there as well. So
Yeah,
yeah.
that's right. I mean, Ken, I think you can answer that. I think.
It's I think that you just having them there is necessary, right? It really is important, and I don't know how we can emphasize that anymore, right? Is that it's like it's important there for the knowledge, but also for the optimizers. Some of the optimizers can take advantage of those relationships there and do things like join elimination. But it can't do join elimination if it doesn't know what the relationships are between all the tables. Like if it can't see, and our friend Steve Berskowitz, who used to work with us at Snowflake, he's mentioned graph models in one of his questions. But yeah, it's the interrelationship there. You have to be able to see all the relationships. If you're writing a query that needs data from table A and table B, if you don't know how it's connected, then there's no way you can make it faster, right? You can't skip things. And, maybe the relationship goes from table A to B to C, and then there's a relationship from another table to C and to A as well. And it may be able to skip around and not have to follow and necessarily join 5 or 6 tables to get the answer. It might be able to skip and join 2 or 3 tables. But the only way the optimizers are going to know that, and this kind of gets into the AI and machine learning even, is it has to have a full understanding. And that's one of the roles that constraints play.
Having that information up front for the optimizer, it's always the best way to do it, right?
Yeah, and that's a huge value.
You can calculate the performance up front for you, and you can make faster queries and make things easier, right, for you.
Yep. So another question, actually, I'm going to answer this one because it can be a self plug here. So what are some good recommended data modeling tools that can do these types of relationship discovery? So I'm going to promote, here, SQL DBM. We have what we call suggested relationships. So what we can do is, based on the patterns of what you're using within your data structures, we can parse that and identify, and suggest we think these are the parent-child relationships and where you should have for foreign, primary keys and foreign keys types of things on those. So if you have a database platform that has many orphan tables and don't have those defined as primary key, foreign key, SQL DBM as a tool can help you discover that. So I'm going to go to the next question, which I think is probably on a lot of people's minds, and I know we've talked about it. Let's talk about AI and ML, and where does AI and ML fit in the data modeling? Is AI going to do all the data modeling for us?
No,
I'll throw that one at you.
Definitely it's not. I mean,
no, not yet. Right. And yeah, there's 2 aspects. We'll hit this one first, and then there's what's the importance of data modeling in an AI ML world? But yeah, this one's coming up more and more. Every conference you go to, every webinar, it's like, well, can't we, if data modeling is so important, can't we just have an AI do the modeling? It's like, well, how is the AI going to understand those relationships? So you've got, I know early on in the data science area, they said, well, we did data lakes and, a bunch of files on Hadoop. And well, the data scientists, those guys will go and they'll do, what we would call data profiling, and they'll figure out how this stuff's all related. And, now we're down to everybody knows very well, the statistic that, 60 to 80% of the time a data scientist is working is basically what we would call data wrangling. They're trying to figure out how the data is related before they try to feed the data into a machine learning algorithm. They have to understand the data. The machine learning algorithm is not going to figure it out. And we haven't got AIs yet that are necessarily going to figure it out, though I think we're going to get closer and closer under certain circumstances. with very well, I'll say well-structured data, that have naming standards. You talk about, the table names and the column names are following some kind of a standard. Then just like with SQL DBM's ability to infer foreign key relationships, that's kind of the level it's at. Okay, we can have some rules and say, well, if we have integer data types and the column names are the same and they're in two different tables, that's probably a foreign key. Okay, but how do you figure out if it's a multi-part foreign key, right? If there's 3 IDs in one table and 2 IDs in another, is there some weird foreign key relationship there? The information has to be there. So I don't think we're going to get there quick. And we all are very well aware of, the hallucinations that people are seeing with ChatGPT and other LLMs. So even if you had an AI that could, say, propose the data model, you're still going to need someone with experience to review that and QA it and make sure, yes, this is an appropriate data model for the data that we're dealing with. And that gets us all the way back to our original discussion about understanding the business and the domains. Somewhere in there, you've got to get that information in. And yeah, I can conceive of a time where, you may be able to have an LLM that is consumed all of this domain documentation, right? Assuming documentation existed, right? That explains finance and how finance works in my company. And there's enough of that, and then access to, maybe some of the database systems that exist that, okay, you could say, okay, propose an analytic data model that will solve and answer this list of questions. Okay, I think we could get there, but we're not there yet.
Right.
Yeah, I definitely don't think AI will create models for companies yet, like Kent was saying. Although it can create some like initial stages, right? It can propose you some initial type models for maybe industry type models, right? But definitely every company is different, right? Every company has different business rules. Every company needs different data process be differently, right? So in my opinion, AI will be good, just to start with initial type data modeling generation, but definitely not going to be able to generate that model for you fully yet. I mean, it's, there's plenty of like conventional database stuff going on, right? There's like this RDBMS versus vector database, right? And vector database are used for like these LLM Gen AI type use cases, right? But still, I have this picture in front of me, like this of like pile of garbage of data sitting on top, right? And there's this guy saying, "Is this your my machine system learning?" And this guy on top of this data garbage of data is saying, "Yes, this is the pile of linear algebra, right? That collects answers and gives you answers on the other end, right? Collects the questions and gives you the answers on the other end, right?" And what if the guy was saying, what if the answer is wrong, right? In this case, well, just steer the pile and keep working on it again.
Stir the pile.
Yeah, stir the pile and keep working on it again. No, it's like you need to have relational databases first upfront. You need to collect and organize data, upfront in a normalized way. Then you can feed that information into vector database. You can feed that information in the LLMs and Gen AI, right? Because all it is, like OpenAI right now, it's like collecting all this information from the web, right? And it, like you said, Keith, like it can hallucinate, right? It can give you like bad answers, right? Like it can provide you like domain knowledge deficit, right? And like inaccurate info, and maybe if they refine tuning the information, right, which is like very expensive process to continue the training all the time of the new information, maybe over time it's gonna forget about the previous information that it was trained on, right?
Yeah.
So that's the thing, and also it can failure with reasons, right? just think about what vector database is. I mean, it's just relationships and similarities of different words and chunks of text, right?
Yeah.
So it's not gonna build your
But
data
yeah,
model.
and I think, back in the mid 90s, I wrote a book called the Data Model Resource Book, which had, we called them universal data models. And so there's examples out there. So you could start with that sort of thing. But like you said, every business has its own little nuances. Even when we wrote that book, we said, okay, based on our experience, here's some standard models you could start with. And so maybe that's kind of one of the ways this could go, is you've got some basic, somewhat standardized models for various industries and various domains that you could start with that, but somehow you've got to be able to then weave in the specific business rules and nuances within an individual organization. We might get there, but again, we're back to somebody still needs to validate all of that, and you've got to have it, I'll say, more controlled. It's not just go out and just scanning the world and pulling it together and going to come up with the right answer in a lot of these cases.
Right.
It's got to be a lot more controlled.
It can accelerate, the development and the development of data models. You can ask, the AI to generate you this standardized
A starting point.
Data model industry type data model. But like you said, every industry, every company is different, right? But what about like PII and PHI data, right? Once you have to have governed data model and database in place, right? You can't just feed every piece of information from your company to LLMs and imagine these magical answers, right?
Yeah, and that actually kind of leads me over to the second part of the AI ML question, is how data modeling could support and help enable AI and ML. And what you just said is kind of the key. It's like all that information, the metadata that we could derive from a good model, and tagging, right? Snowflake has tagging. So tagging things as, these elements are PII data and PHI data, potentially with a good data catalog and a good ontology and taxonomy, you could maybe get to the point where an AI might be able to, project and say, okay, these elements are probably PHI data and PII data. But getting all of that together, to my mind, in a good data model and a robust data model, as a feeder into an AI and machine learning algorithms, in order to give it that information, so we eliminate some of the randomness of the interpretation on the LLM side. I think we saw a good example of this at the Data Vault conference with one of our friends from Finland, who was demoing some of the things, some of the AI capabilities in Oracle, and she got very, very specific in her prompt engineering and basically saying, here's a table definition, here's some foreign keys, and then asked the question. Okay, and then the question came out and had a much better answer than just say, well, look at the database and give me an answer. When you specifically gave it that extra metadata, the answer got better.
Right. I view here, there's a question that says, which would be faster, having a domain expert create a data model from scratch, or having a domain expert clean up the hallucinated AI generated data model? And to me, it's kind of like a chicken and the egg scenario.
That's a good question.
Right. I mean, I could, from my personal perspective, I've used AI, into what Marcin's point, as to accelerate my ability, because getting to the monotonous stuff of typing in column names and table names and all of that stuff, if I can sit there and say, this is what I want, but to your point, I'm giving the verbal input of what I want, my interpretation. You're just doing I'm gonna call it the tedious stuff for me, right? And it's that balance of, I'm going to use AI to accelerate my vision of what I want for an architecture, what I interpreted from my conversations with the business, because the AI wasn't sitting there having the conversation with 3 or 4 people, right? So I interpret it, I input to the AI, it brings me back, and then I adjust and tweak. So to me, it's kind of like, I use it as an accelerator, but it's not replacing my experience of how to interpret a business, I would never sit there and say, generate me a point of sale system model and then implement it thinking it's going to work 100% for that given
Yeah,
organization.
so a year ago, back in I guess that was 2023 at the Data Vault conference, one of the Snowflake, I think he was a field CTO, Dimitri, who's over in the UK. We went to ChatGPT and said, generate a Data Vault model off of the Snowflake TPCH shared data model, right? And it came out and it was pretty good. So, to answer your question, Steve, it's like, yeah, that actually, given those constraints, giving that the source system, the TPCH model, is a well-formed third normal form model, and ChatGPT knew enough about Data Vault and how Data Vault would structure things, it actually came up with a pretty good first cut model. And we looked at it and said, yeah, okay, that is a great start. So, definitely to Keith's point is like, we can start with that, and that can, like you said, maybe accelerate it. But something, Marcin, you said earlier about the cost of training these LLMs is there's not been a lot of discussion there about, there's the cost of, okay, say having Keith build the data model from scratch versus the cost of training the LLM to accelerate Keith. There's an economic balance there somewhere of the compute cost to have trained the LLM to be able to be that kind of assistant. And
going back
not
to
a lot of people are doing that kind of math.
Yeah, but going back to that question, I wouldn't fix the model with like AIs, right? Or feeding the information back to the AI and start asking questions and maybe fine tuning this way. But this go back to this steering the entire pile of data garbage, right? You want to go back to your original data model. You want to fix it there, right? In your whatever it's the data vault, Kimball, third normal form, right? You want to be able to fix it there, because you're sharing that data collaboratively across the organization, right? You're generating the reports, you're using it for ML, models. You're using it for like maybe feeding it to another system, right? So to answer that question, I wouldn't be able to, use AI to fix all that the information through using AI, because that's just silly, in my opinion.
Well, and actually, again, back to our earlier conversation about the lack of training in data modeling from an academic perspective. Part of the thing that we've, I think, all discerned here in the last 6 months at least is there's an art to this prompt engineering thing, is asking the AI the right kind of questions in the right way to get a good answer. And if people don't understand the fundamentals of normalization and data modeling, how are you going to ask an AI to build a data model? I mean, it's one thing is like, it might build the data model, but do you even have a clue that it's right? And if you do have a clue that it's right, do you understand the relational design well enough to ask and prompt it another way to get that refinement where, if you've got an experienced data modeler, they can take that first cut model and go, oh yeah, I can just fix this. And it's going to be way cheaper to do it that way.
I was thinking about AI, like this Gen AI and like LLMs, like for SQL DBM, that would be cool for somebody like you and I can like draw something on the piece of paper, like a drawing on a napkin, right? Feed it, take a picture of it, feed it to an LLM, right? And come up with SQL DBM data model. Why not?
Ooh, I like it. There's a new product idea for you, Keith.
The product people are on right now. Let me look over to my Slack here and see if there's craziness going on. But I do think, there is, much like many things in life, right? There are tools, and you can use these tools appropriately. And you can, I often use like, cooking analogies and stuff like that, right? You could have the best stove in the world, but it's not going to replace the chef, right? It's just going to help the chef be able to cook better. And I think the same way where we are from an AI is, it can be used as a tool to accelerate, to help. But I don't see it replacing me anytime soon. We have another question here, which kind of goes back to, I'm going to say, the basics. And here it's like, many of the times I am facing a lot of issues making clients to understand, I'm assuming to understand the benefits of data modeling. That's going to be my interpretation of this. So I would say, what do you guys think? What would you say? I'm sure we've all experienced, I'm sure even Marcin, you going into clients who are looking at Snowflake in terms of, getting them, you talked about the monetary value, but what do you say in getting organizations to understand that the benefit, right? Or getting them to
Yeah.
understand the value of doing data modeling.
So every organization, they have many different source systems, right? If you can't process all the like many different source systems at a time, right? You have to organize them in one singular data model, right? You have to organize, like, organization can't have like 10 different customer tables, right? In my opinion, there should be only one customer table, whether it's called a party, whether it's called a customer, whether it's called a client. It should be one customer table. It should be shared collaboratively across the organization, and it basically the whole data modeling, the value of data modeling, right? It basically accelerates speed to market, right? Once you have that singular data model normalized, with reduced data redundancy and promoting simplicity and flexibility, basically you can build systems very fast and very flexible and quality on top of it.
Yeah, no, Steve, in one of his questions, he said he's become a believer in 6 normal form, which is called graph normal form, fully normalized. And I'm with you on the 3rd normal form, but I do agree with Steve on that. Is like, you really wanted to get down to it, that's as flexible as it can be. It's eminently extensible, right? Because it's just, you're adding a new object and a new relationship as you discover new things. And then I think from an implementation perspective, then depends on the platform, right? Some platforms, a 3rd normal form model is going to be really the best way to implement it. And others, if you're doing analytics, it might be dimensional model, might be the better way to implement it. But boy, if you start at that fully normalized understanding of the data, then it's a lot easier to add on. And a lot of relational databases don't necessarily like that. Of course, the graph databases, that's what they're built for, is doing this sort of thing.
Well, the main issue here is like it prevents the correction of errors associated with like misunderstanding.
Yeah, the update anomalies. That was the thing that got me about learning about normalization when I first learned about it back in the late 80s. Is like the whole idea of eliminating update anomalies was the key that got me. It's like, you're building systems, you're loading data. How do we keep from having, a customer address stored in 2 different places and the addresses are different, right? And that's where normalization came in. So directly to your point about, wouldn't it be great if every organization just had one customer table?
Exactly.
Because in the SaaS world, I don't know how we pull that off.
Yeah. It goes back to this, decreasing system maintenance time and costs, right?
Yes.
That's where it all goes back to. That's the main reason to have that data model.
Yeah. Well, this was a fantastic conversation. I loved all the questions we got from the panelists. Just a few things in closing. I know, and I'm going to quickly share my screen for everybody. But I do know, for any of you who are, I'm going to make sure, can you guys see my screen? So in a couple weeks, I think, exactly 2 weeks, I know myself, Kent, and Marcin will be at Snowflake Summit. I am going to paste into the chat. So at SQL DBM, we will be having a booth there. And this is the landing page to the information about us at Snowflake Summit. I'll kind of go through. Marcin will be at the, you'll be able to find him at the Snowflake. I think he said what, the financial booth with Snowflake. Obviously with us at SQL DBM, if you do want to book a meeting with us while we are there, if you're going to be there, there is a link here to book a meeting. We will be conducting demonstrations of SQL DBM every day. So 2 or 3 demonstrations a day. We will have a demonstration theater right at our booth. We also have we'll have of our clients like DirecTV, partners like Passerelle, who will also be at our booth, kind of talking about their use cases and uses of SQL DBM. For those of you guys who may know Serge or have his book or would like to get his book, he will there be doing book signings. We will be having a Data Speakeasy happy hour. You can RSVP here from the website. Kent will be joining us at our booth on Wednesday. So come on by the booth and come in here and talk with Kent. And we'll have another variety of actual sessions that we are participating in at the Snowflake Summit. We have a client Survey Monkey who will be doing something. I will be discussing the core components of data modeling success. And then Serge on our team will also be talking about collaborative cloud data modeling. And come by, register, get yourself a free Apple Vision. But with that, again, I want to thank Kent, Marcin for joining me here today. This was always fun to talk about data modeling, and I thank you both.
Thank
Thanks
you,
for
guys.
having us.
Thanks.
Thanks, everybody. And
See
this
you
will
in San
be
Francisco.
yes, we'll see you there.